Hey Pre-Cal students, I am interrupting my binge watching marathon of SVU to start some notes back after spring break. I hope all of you had a wonderful spring break, as much as you could have in the middle of a pandemic. And we're going to pick up in section 2 of chapter 7. We are learning some more formulas, and so you really just have to memorize them. And you do need to know them. So let's take a look at what we have. We are looking at addition and subtraction formulas for sine, cosine, and tangent. So if you look at sine, here we have an addition formula that looks like this. Sine x cosine y plus cosine x sine y. So it's addition. Notice it has the addition sign. The subtraction one is the exact same formula, except instead of addition in the middle, it is subtraction in the middle. So the way that I remember this one is I remember South Carolina is a cool state. I'll say that one again. South Carolina is a cool state. That's the mnemonic device I use to remember the addition and subtraction formulas for sine. All right, then we get to cosine, and it's different because the addition formula for cosine actually does not have addition in it, it has subtraction, and the subtraction formula for cosine has addition in it. So for cosine, you are using opposite signs of what you have. So if you're using the addition formula, you have a subtraction sign. If you're using the subtraction formula, you have an addition sign. I do have a mnemonic device for this one. Another teacher taught me this, and this is not something that I believe, so don't hold this against me. But what she said was Charleston County schools stink. Now, I don't really believe that Charleston County schools stink. Not at all. It's just a mnemonic device to help us remember that. So Charleston County schools stink. That will help you remember the order that needs to go. All right, then we get to our tangent ones, and they look kind of similar, the difference being their signs, and my dogs are yapping out there. Hopefully they'll stop. Okay, so tangent. If we are using the addition one, then in the numerator you have addition, and then the denominator you have subtraction. If you're using the subtraction formula, you have subtraction in the numerator and addition in the denominator. So whatever formula you're using, that's the same sign you're using in the top of the fraction, but in the bottom of the fraction you are using something different. Do have a mnemonic device for this one. So Tim Tebow won 2 trophies. Tim Tebow won 2 trophies. So we have South Carolina is a cool state. Charleston County schools stink. No, we don't really believe that. And Tim Tebow won 2 trophies. So that will kind of help you, I think, in learning these fairly quickly. What we're going to do today is work on part 1 of the notes. And then your homework for tonight is going to be to do the problems that are in your notes for part 2. And then tomorrow I will have those notes on the website for you to check your work. So let's get started with example number 1. We're being asked to find cosine of 75 degrees. So to answer the question, because you might be wondering, why do I need to know these formulas? 75 degrees is not one of those numbers that we know from the unit circle. Remember, in quadrant 1, we know 30, 45, and 60. And then in all the other quadrants, we have the other numbers as well. 75 is not one that we know. But if we don't want to have to use a calculator, because up until now, at this point, we would have to use a calculator to find cosine of 75 degrees, we now can use an addition or subtraction formula. So you want to try to think, okay, what numbers can I either add or subtract together to get 75? And there's probably lots you could choose from, which is why different people's work will look different. And then their answer, though, at the end of the problem should be the same, and it all depends on did they add or subtract and what numbers did they use. Me personally, I like to try to use quadrant 1 if I can, just because quadrant 1, you know, when you're doing sines and cosines, everything is positive. It's easier to work with in my head, but you're welcome to use whatever numbers you want. But I think I'm going to go with changing the 75 to 30 plus 45. And you'll have to bear with me, I'm writing slower because my carpal tunnel has been on fire lately, and so writing is going to be a little bit of a struggle. Okay, so I've just changed the 75 degrees to 30 plus 45 degrees. And so for cosine, that's the one that is Charleston County Schools stink. Since this is the addition formula, remember with cosine it's different. You actually don't use addition. So here we go. I'm going to use subtraction. I'm going to have Charleston County, and I'm going to use subtraction, schools stink. Again, remember, we don't really believe that. That's just what we're saying. So now that we have that written down, we got to remember the unit circle. Now, if you need to draw a unit circle, you can. I'm really hoping, though, this is the 3rd chapter we've been working on the unit circle with. Hopefully, you kind of at least have quadrant 1 values in your mind pretty quickly. So let's think about cosine of 30 degrees. Remember, cosine comes from your x-coordinate of the ordered pair at 30 degrees. So at 30 degrees, the x-coordinate would be the square root of 3 over 2. And then at 45 degrees, the x-coordinate is the square root of 2 over 2. And we're going to be multiplying those together in just a moment. And then sine of 30 degrees, well, sine is the y-coordinate. And so at 30 degrees, the y-coordinate is 1/2. And at 45 degrees, the y-coordinate is the square root of 2 over 2. So now I'm going to multiply together. So square root of 3 over 2 times the square root of 2 over 2 is the square root of 6 over 4 minus 1 over 2 times the square root of 2 over 2 is the square root of 2 over 4. Now you certainly are welcome to leave it like this, but they already have a common denominator, so it couldn't hurt to go ahead and put them together as a single fraction. I would be okay with either answer though. And so there's our final answer for cosine of 75 degrees. All right, so next we have cosine of pi over 12. Well, I remember that you guys typically are a little bit better with degrees than you are with radians. So let's go back to chapter 6 for a moment, shall we? We have pi over 12. We have radians. If we want to change radians to degrees, we're going to multiply by 180 over pi. So the pi's, they're going to cancel each other out. We're going to be left with 180 over 12, which turns into 15. So I'm going to just rewrite this as cosine of 15 degrees. So my next question to myself is, how can I get a 15? What numbers can I add or subtract to get that? And guess what? I can use the same numbers I used a moment ago, but 45 has to come first because I'm going to be subtracting 45 and 30. And I'm using the difference formula for cosine. So Charleston County. Then since I'm using the subtraction formula, I know I'm using addition really. Charleston County Schools stink. And I know this thing is shaking, I'm sorry, y'all. All right, so cosine of 45 degrees, that is the square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2. Sine of 45 degrees is the square root of 2 over 2. And sine of 30 degrees is 1 over 2. So when I multiply, I've got the square root of 6 over 4 plus the square root of 2 over 4. And again, if you want, you can rewrite that into a single fraction because they already have a common denominator. Whoops. Okay. So hopefully you're seeing that these really aren't that hard. It's just a matter of you got to know your formulas. in your unit circle. Remember, that thing is coming back, y'all. I tell you all the time, gotta know the unit circle. All right, moving on to example number 2. It says find the exact value of each expression. So I'm looking at letter A, and it has 20 degrees and 40 degrees, and neither of those are numbers that are on our unit circle. So this one's got sine, cosine, cosine, sine. That's the South Carolina, is a cool state. That is the sine formula. And remember, with sine, oh dear, me and lead don't go together. With sine, whatever sine is sine, not sine, but sine, S-I-G-N, is in your problem, that is what your formula is. So because I see addition, this is the addition formula, where we're going to be adding the 20 and the 40 together, which now means we have sine of 60 degrees. And good news, that one is a unit circle value, so sine of 60 degrees. We're looking for the y-coordinate, and that is the square root of 3/2. So that one's pretty easy. So let's take a look at the next one. This is clearly going to be one of the tangent ones. So what we need to ask ourselves is this going to be addition or subtraction? So you might remember that I told you guys that with the tangent ones, whatever sign is in the numerator is the sign of what the formula is. So I see addition in the numerator, so that's going to be addition in here. So we're going to be doing pi over 18 plus pi over 9. Then we're going to add those together. We need a common denominator. It's going to be 18. So pi over 9 turns into 2 pi over 18. So if I add pi over 18 and 2 pi over 18, that is 3 pi over 18. And 3 pi over 18 reduces to pi over 6. I'm going to leave it as pi over 6, but you might also remember that pi over 6 is 30 degrees. So let's talk about tangent at 30 degrees, or pi over 6. Tangent comes from y over x. So the y-coordinate at 30 degrees is 1/2. The x-coordinate at 30 degrees is the square root of 3/2. I'm going to turn this into multiplying by the reciprocal. Good news is our 2's cancel out. Bad news is we have a radical in the denominator. So I'm going to have to rationalize this. So I'm going to multiply the top and the bottom by the square root of 3, and I'm going to end up with the square root of 3/3. Now you may have already memorized what tangent of 30 degrees is, and if you have, then you could save yourself some work and not actually have to show any of that work. You could have gone straight from here to here. So if you already have that memorized with your unit circle, then kudos to you. That makes this problem that much easier. All right, example 3, we're going to verify the identity. So we've been working with identities in section 1. We spent a whole week on that section. Remember, you start on one side. You start on the side that looks like it is more complicated. So I'm going to start on the left, and I'm using the subtraction formula for cosine. So cosine's mnemonic device is Charleston County Schools stinks. Also remember that for cosine, you're going to use the opposite sign. Oh, those dogs won't hush. The opposite sign of what you see. So I have cosine of pi over 2. That's Charleston County. Then I'm going to use an addition sign, and then schools stink. All right, so remember pi over 2 is 90 degrees. So let's think. Cosine at 90 degrees is 0. And sine at 90 degrees is 1. Oh, can you hear them? They're so pitiful. Scratching on the door. All right, so 0 times cosine of u, that's going to cancel out. 1 times sine u is sine u, and that's perfect because the right side of our identity is sine u. So we have very quickly and easily verified that identity. No, shut the door, please. Thank you. Ay, ay, ay. Kids and dogs. What do you do? Okay, example 4. We're going to start on the side that's more complicated. Neither side looks particularly easy, but we're going to start on this side because we're going to use our tangent formula. Oh, one of the dogs snuck in the room. Hold on. Coco. No, ma'am. Going after my jelly beans. That is not okay. The Easter Bunny left that for me. All right, here we go, y'all. So this is the one where we do Tim Tebow 1, 2 trophies. All right, so we're using the addition formula. That means we're going to have addition in the numerator. So here we go. Tim Tebow. All right, in the denominator, now we have 1. Then in the denominator, you use the opposite sign, so we're going to use subtraction. And then we're going to do 2 trophies. So Tim Tebow 1, 2 trophies. How's that looking? All right, pi over 4. Well, pi over 4 is 45 degrees. So tangent at pi over 4, that's where you're going to do y over x. So you would have the square root of 2 over 2 over the square root of 2 over 2, which is just going to give you a 1. So we have 1 in place of tangent of pi over 4. And then in the denominator, tangent of pi over 4 is also a 1. And what happens when you multiply 1 times tangent, or tangent x, I should say, you just get tangent of x. So our numerator is 1 plus tangent x. Our denominator is 1 minus tangent x, which looks exactly like what was on the other side. Sorry, I'm hustling through this because my carpal tunnel's bothering me. Otherwise, I would rewrite that over here. Okay, last example. This one says that this is an identity from calculus. So for those of you that might be interested in taking calculus next year, we might revisit this again. It says if f of x equals sine x, show that f of x plus h minus f of x over h is equal to this lovely thing over here. So we're going to be starting over here, and we're going to see if what we get over here equals what we have over here. So let's talk about f of x plus h. What does that mean? Well, you know that f of x is sine x. So f of x plus h means we're going to have sine of x plus h. Remember, this just means that you're going to plug in an x plus h everywhere you see an x. Does that make sense? So in place of f of x plus h, I have sine of x plus h minus, in place of f of x, I'm going to put sine x, and then all of that. Man, this lead. And I'm using 0.9. Should not be breaking. All right, so let's use the addition formula for sine. South Carolina is a cool state. Here we go. So South Carolina is a cool state. All of that right there is the sine of x plus h. Then we have minus sine x. And then all of this is over h. Okay, so we have a whole lot of letters, don't we? Let's see. So I noticed that this has a sine x and this has a sine x. What if we put those two things closer together? So if I put them, there's that one. I'm just really changing, I'm just moving that here. I hope y'all can see that. Now here's what we know. We know that all of that is over h, but what if I broke it up into two fractions? So instead of putting all of it over h, I make two separate fractions and they're both over h. Let's see if that's going to help me out. So let's look at this first fraction. What do they both have in common? They both have a sine x. Oh, Coco, please stop. So if I take that out of the first one, I'm going to be left with cosine h. If I take it out of the second one, there's nothing left, but I can't have nothing there, so I'm going to have a 1 in its place. And then I still have my denominator of h. All right, so look what we have so far. We have this, and it matches this perfectly. So now here's what I have for the second one, and really all I have to do is make it look like this one right over here. So I'm just going to take that cosine x, move it outside of parentheses, and put the sine h over h in the parentheses. See what I did there? Just a little bit of math, and it looks exactly like that. And ordinarily I would write that down, but my wrist is bothering me. Okay, so your homework for tonight is to try the 7 examples for part 2. Tomorrow I will put the notes up for that on the website so that you can check your work. The other thing that I would say for your homework tonight, because you do only have 7 problems, which isn't too bad, right? I would encourage you to make sure that you take the time to memorize these. If you can remember those 3 mnemonic devices. So the one for sign is South Carolina is a cool state. And when you're using the addition, you use an addition sign. When you use the subtraction formula, you use a subtraction sign. For cosine, it's Charleston County schools stink. If you're using the addition formula, you really use subtraction. If you're using the subtraction formula, you really use addition. And then for tangent, it's Tim Tebow 1-2 trophies. If you're using addition, your numerator has addition and your denominator has subtraction. If you're using the subtraction formula, your numerator has subtraction and your denominator has addition. Hope you got all of that, and I will see you guys for the next video for the first half of 7.3. Bye.